Okay, today in class we looked at the quadratic formula again. I didn't really teach anything new today. I did go over for a second about when do we want to use each way of solving quadratic that we know. So we do know several ways, and the book talks about a few. We've taught things out of order in the book. So one thing it talks about is graphing. We haven't done that yet though, so we're not even going to talk about when we're going to use that. We're not going to even mess with that one yet. There is, if we have a perfect square on one side, how do we solve something like that? We can solve things by factoring, solve quadratic equations by factoring, by completing the square, and by this new thing we have called the quadratic formula. Here's the deal. When we start doing this, we're never going to solve anything by graphing. We might, once we start looking at graphing, we want to be able to graph these things, but we're not going to solve them by graphing. We really aren't going to solve anything by completing the square either. This, keep in mind that there's that b squared, b over 2 squared to complete it. But other than that, we don't really worry about that one too much. And this one, you'll know when to use that you have a perfect square, mostly because if you see a perfect square there equals something like, I don't know, x squared equals 25, you'll do it and it'll be easy. Factoring and quadratic formula are all we're going to use, really. When do we use factoring? When it's factorable easily. Don't waste a bunch of time. If you can't figure it out easily, don't do it. Go to the quadratic formula. The quadratic formula, when do we use this? If it's not factorable. If you have a quadratic equation that's not factorable easily. So it might be factorable, just might not be factorable easily. What I mean by easily is this. This quadratic, we can factor easily, x minus 4, x minus 2. Why waste time using the quadratic formula? This quadratic, x squared minus 16x minus 57, maybe that doesn't factor quite as easily. Maybe you sit there and you go, oh man, I don't know, I can't think of it. So you use quadratic formula instead, and that's probably okay. That'll work on that one. The cool thing about the quadratic formula, this always works. Quadratic formula always works, doesn't matter what it is. Factoring doesn't always work unless it's factorable. So always works, not always, but when it does, factoring is way better. Okay, you had a couple problems on your homework. It's just doing the quadratic formula. I'll do a couple of these, but I don't want to get too crazy on this because I do want you to try some of these on your own. Here's 7. 3x squared plus 40x minus 128 equals 0. In fact, I really think I'm just going to get these set up for you because you should be able to do everything after the setup. Put it into the quadratic formula. X equals negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. And you can go from there. Maybe 15. 3x squared minus 11x minus 2 equals 0. Let's just put it in the quadratic formula real quick. Negative b, which is positive 11 plus or minus square root 11 squared minus 4 times 3 times negative 2 all over 2 times 3. And we have that solved. Okay. Let's skip down to the 19 to 23 because that's what I really want to talk about for a second, and then we'll go from there. 19, it says, would you use factoring or the quadratic formula to solve this? Well, what you should be thinking is perfect square, I would factor this. That'd be 2x plus 9, 2x minus 9. I see that, it's easy. I'm going to factor. Why waste time doing quadratic formula if it factors that easily? 21 says 3x squared minus 5x plus 9 equals 0. Factoring or quadratic formula. Does that factor easily? Not really. It's not totally obvious to me right now, so I'm going to use quadratic formula. If it's not totally obvious or pretty obvious, I'm going to use quadratic formula. When it is pretty obvious, you need to factor. We're going to factor if it's obvious. 23 says negative 4x squared plus 3x plus 2 equals 0. Again, is this going to be totally obvious? No, probably not, so I'm going to use quadratic formula. Most of the time, if this isn't a 1 here, I'm not even going to mess with trying to factor it. It's just going to be a waste to do that, so we'll use quadratic formula. It's not that it's impossible or super hard or anything. I just don't want to waste time doing it if I don't have to. Let's skip. Let's go look at maybe maybe we can get you set up on 37 real quick and then let you get going. 37 says you have a triangle like this. The height is x, the base is x plus 6, and the area is 50 centimeters squared. It says find both of these. Well, how do you find both of these? 1/2 base times the height equals the area. Simplify, I'm going to get 1/2 x squared plus 3x equals 50. That's a quadratic. To solve it, factorable? No. Quadratic formula, minus 50 minus 50. 1/2 x squared plus 3x minus 50 equals 0. And quadratic formula from there, we can even plug it in for you. Negative b, negative 3 plus or minus square root of b squared minus 4 times 1/2 times negative 50 all over 2 times 1/2. So when you use quadratic formula, just plug it in. I'm not doing the work for you, mostly because I think you can do the work, and it seems dumb for me to be doing it for you when it's really just the algebra stuff after that. I am going to leave 42, which is kind of hard. I'm going to leave that to you. You just have to add those two things together, so get a common denominator and cancel things out that need to be canceled out. Okay.